This is a session about open source summit serverless track, and I'll be your host tonight. We have an awesome session. Let me introduce you to the panelists here. We have Pav Jimanov, a principal SoftwareDefined, and Burton Rheutan, DevOps lead OpenFast core contributor. And we have Yaron Haviv, CTO Iguazio. Welcome. Thank you. So in this session, I'll do a quick overview of serverless, and then using OpenFaas and Nucleo, the panelists will present real use cases and demos to highlight on-prem usage of serverless and containerization technologies. After the presentation, we'll have a Q&A and a roundtable. So a little about serverless, and this is more obligatory. I do it every time we just talk about serverless. Just like wireless, where there are no wires, but there are wires somewhere. We all know that. Same way, serverless architectures have servers. It's just not yours. And what serverless really means is that as a developer, you don't have to think about servers, managing, patching, or upgrading servers, right? There are servers, but you don't have to manage them. You just focus on writing code and deliver on business outcomes. This is a great quote which kind of sums up what serverless really means. That's by Martin Fowler from ThoughtWorks. Serverless usually refers to an architectural pattern where server-side logic is run in stateless compute containers, and just take a note of containers, and that are event-triggered, ephemeral, and fully managed by third party. So that kind of sums up what serverless really means, right? And we'll go over this whole conundrum about serverless versus container. I always hear this debate, what is better, what is not. I feel it's a complementary technology, right? Running side by side containerization. It's not a debate which technology to use or which one is better. We need to be wise enough to decide which one to use when. The theme of this session today would be kind of focusing on that part. And we have OpenFaas and Nucleo kind of go over some real use cases and scenarios that kind of showcase how serverless technology can be working side-by-side containerization technology. So with that, let's give it out to Burton, who will start with the OpenFaas, and then we'll go over to Pav. Here you go, Burton.
All right, thank you. So I'm one of the core contributors to the open source serverless framework, OpenFaas. The project began right here at the DockerCon, not in San Fran, but 2016 as a Docker hack to enable Alexa communication with containers. Since then, it got added to the CNCF landscape and the serverless, and has grown to over 200 contributors. We have over 29 companies using us in production. We've won 2 BOSI Awards, for Best Cloud Computing Software. This is the serverless function that generated the avatars of all of our contributors at the moment, as of yesterday. So the core values of the OpenFaas is true serverless. We're developer first, but we're also operator friendly and community centric. Right, so developer first, we have function templates pre-built, ready to go for you, with some of the security best practices in place, with C#, PHP, Python. There's also a template store. So community-created templates get added to a store and easily added with the CLI. So some of the more fun ones, PowerShell, Rust, and Crystal, if anybody's heard of it, are all available. So when you create a new OpenFaas function, the box there in center is what you're given, just the code, right? In the true serverless world, all you care about is the code that we want to run. So when you run that, or when you do the fast build, it takes that code, bundles it with our Python template, creates a Docker image for it, and pushes it up to the container registry. And then further down the pipeline, it also deploys it to the cluster that you have provisioned for running your functions. So in the true sense of the word, the developer doesn't care where it's running or how, just on the code that is created. So calling your functions in any sort of event-driven way. So Kafka, we have a Kafka connector, so we can plug into events driven through the Kafka. Cloud events, which is one of the CNCF sponsored standardizations for events. HTTP, of course, SNS, MQTT, NATS, all the great ways that you can asynchronously invoke code. So like Rupak said, there are actually servers running serverless functions, believe it or not. But you can have almost any server you want. So we support Docker Swarm, Kubernetes, HashiCorp Nomad. We have some AWS Fargate. Also, shout out to the DockerCon Platinum sponsor. You can run it on ARM already. It's also super lightweight. So we're talking megabytes worth of binary to add to your cluster. You would never notice it at an operational standpoint. And we deploy everything in separate namespaces so they're isolated from your normal applications. So then flipping over to the operator side, it's all just containers, right? There's no special magic happening here. So there's an ingress load balancer that goes to the OpenFast gateway. That gateway coordinates which functions get executed. We plug into Prometheus and Alert Manager to handle the scaling up, down, and to zero. We also have an operator for Kubernetes native with a CRD, so you can do kubectl function, all that fun stuff. So it's very familiar on the operation standpoint. Right? If your operators know how to run Kubernetes with containers, they're going to be comfortable with OpenFaas running as well. So some of our production users, if you notice, there's a couple pretty big names in there. There's some banks, a couple of cryptocurrency companies. We're very popular in that you define your own limits. If a language isn't supported that you need it, we can run bare Docker images, so you can build your own templates from scratch. You can set your own limits and timeouts, and you run anywhere. So if you're already using Swarm, keep using Swarm, add serverless on top. Kubernetes, same. So we ask that you join the community. Like I said, we're very community-driven. Most of our features are from you, asking if we can do something, and we generally say yes. But it's also very open. If you've never written code, we can help you. We have documentation, all the fun stuff. We also have a self-driven workshop. It takes generally about 3 hours. It'll step you through every piece of the core functionality of the serverless, of the OpenFaas, to get you started, let you know how to do asynchronous functions, function chaining, secrets, all the good stuff. I also want to remind everybody it's an open source project, so please support us. We're not backed by any major corporations, very community driven, so everything helps. So real quick, just to show an example of real world applications here. In this case, we have a Vue.js UI generating, for example, a sign-up form. And there's an API written in C#, just standard, normal applications, Docker containers, normal process. And then you also have OpenFast running on the side. Same cluster, different network, different namespace, depending on what you're running. So the UI calls back to the API to submit the form. The API then is able to call a serverless function that, say, for example, validates an address. So you have that specific code. You know how to check for a zip code is accurate and the state is the right thing. But there's no reason to put that in your application code because you might need it somewhere else. So deploy it to a function. You can call it as much as you want. It'll scale up, down, as long as you need it. And so to demonstrate, Pav here is going to show us a little bit of the portability of OpenFast. So for example, Pav here has Docker Enterprise Edition running a Kubernetes cluster, and then he has OpenFast deployed with our Fastnetties connector that connects the OpenFast framework to the Kubernetes native so that we can do the scaling and the routing and all that. And also to sort of show off the portability, we're going to have a public cloud running Kubernetes, which also has OpenFast, that is then connected to AWS Lambda. So to show you that on the operations standpoint, you can do whatever works best for you as an operator. As a developer, you don't really care what's happening behind the scenes. You focus on the code. OpenFast handles the hard work, puts it in the right place, and executes the code as you need it. So I'll let Pav take over if he's ready.
Just go back. All right, switch it over.
Okay. All right, so let's see here, just a second. We're gonna talk a little bit about how we integrate, how we work with OpenFast. So I personally been involved with OpenFast for the last few years, more on the kind of end user point of view, although I'm also involved as a community. I don't contribute in a way that Burton does in terms of code, but there's different ways of contributing. So if you're not a developer or you're more an infrastructure person, there's always different ways to contribute to the community. So please join the community. It's what I'm going to show you right now, and I might have to. Oh, no, it switches the. Give me a second. So I'm going to talk about it for a second then.
Right.
So, I don't know, you cannot see it all, but
Not yet. I think you just swipe.
can you just use the background on it for the dock? The shell itself.
Display.
Yeah. While he's going at it, I think I should have made it a little less transparent on the shell itself. But basically what we're going to have as far as the setup, I'm going to go through that, and then we're going to show you the demo. We have a FastNeat is basically a fast version of Kubernetes running on the Kubernetes orchestrator hosted by Docker Enterprise. So kind of simulating, giving you a feel about what if you're running functions on premise, right? We all know about running functions, maybe in Lambda as an example, or running serverless as Lambda. But what about Kubernetes? So we're simulating that by running it on Docker Enterprise Kubernetes schedule. Then the equivalent of that, we also have in the cloud, we're running Kubernetes server that hosted directly on one of the cloud providers. And we deployed OpenFast provider that is basically going to help us take a container that OpenFast builds and provides and push it as a serverless function into the AWS Lambda.
Sorry about that.
Yeah, it's usually the difficult part here.
Sorry.
So that's exactly what we're going to demo here.
All right.
Thank you. All right.
I think can you make the shell like opaque, because I think
I gotta show some in UI too if it's that difficult. Yeah.
Okay.
I think it's actually relatively decent. So I'll show you just right now kind of my setup.
Can you increase the font a little bit if you can? Control plus should do it, I think. You're on Mac, right? Command plus.
Yep.
Sorry.
Yep.
Did it?
Yeah.
Do a little bit more.
So we can see right now we're gonna use Fast CLI. It's very much part of the OpenFast.
Which screen are you on?
Obviously.
Are you on this one?
Yeah.
Yes, clear. Yeah.
All right. Well, it's a live demo, so I can't go right.
It's all cool.
So just kind of trying to show that right now, this is on the left-hand side, what we're seeing right now is where I have FastNeat is running on Kubernetes, hosted in Docker AE. So I'm showing there's no function. And right now I have functions basically described, and I'm going to deploy it by basically running just fast CLI command. Fast CLI up, F, and I'm going to specify which basically function I want to deploy. Since in OpenFast, functions are backed by the container, right? You can see right now on the screen, we're actually building a container image, providing logic, right? That what we wrote, the logic for this particular function is getting all put together built as a container, pushed into the registry, and then deployed running in OpenFast cloud. So if I can go into my UI right now, you can see there's OSS function, and if I invoke it, you can see that I'm basically getting very basic system information here. So I'm getting the host name, what type of platform I'm running on, my architecture, and my basically CPU count. So if I go into the same directory right now, and I'm going to increase my font on this a little bit. I apologize for that. I'm going to perform basically the same operation. I'm going to run the same function in the same directory. YAML. So we're going through the same process right now. So this is running on Kubernetes in the cloud, and it's running OpenFast provider for AWS. All right.
See the seamless
It's
local
same
and
yeah,
on the cloud. So you can
same
do the same
function.
thing.
Yep, sorry, same function, same command line, same code, no changes. So I go into a couple ways I can look at this function. So I still have a portal, OpenFast UI, that I can look at the function I just deployed in AWS. So I can see this function running here, and I'm gonna invoke it. And you just can see I have a host name unnamed. I have Linux as my OS, x86 architecture, and I have my CPU count and uptime, right? Which looks a little bit different. The reason it looks a little bit different because there is no host name. Because an OpenFast function runs inside of a container, so it gives the underlying container name. In Lambda, it's not, right? It runs it's in a more of a proprietary format. So here's my Lambda console, right? So let me go and refresh. There's nothing in there right now, but now I can see inside of AWS Lambdas, I have the same function I just deployed through OpenFast showing up. No other setups except for some other security configuration, so I can actually push the provider up to AWS. And now I can go in and create a test function and just, I don't know, just call it some simple test. I misspelled it, but I'm not going to change it. And I'm just going to run it. So now you can see that I'm actually running this function in AWS. I'm getting the output here. Just to kind of add a little bit more, since we're running on Kubernetes, we can go in and just run some kubectl commands too. So kubectl, get pod, put namespace. Okay. And you can see this is actually a pod that's running the logic. This is Docker E, so we can go and just use that too. And you can see right here, I'm actually running a function. You can take it, a step further and just basically, it's ash. It's Alpine, so I'm writing ash. And you can see there's actually a function in there, and this is where my logic is.
Can you clear your screen real quick?
Yeah, I'll bring
That's
it
okay.
up. Yeah, so you can see this is the actual Node.js code. Now, if I do the same thing, it's not going to work exactly the same because, again, there's no concept of pod that running on basically inside of AWS. Probably, yeah, there's probably not much there. But so it's not gonna, there's nothing, there's no resources found. So that's pretty much what you see the ubiquity of container. In OpenFast, it's a container. As a push to AWS, it becomes a Lambda.
Yeah, so I mean, I just wanted to kind of highlight what just happened, right? So on the left side, you saw local. So you can imagine your workflow, dev workflow as local development on your laptop, writing the function, going about your testing, and then when you're happy, you can see it from the OpenFast portal, and you can test out everything. Once you're kind of ready to go, then you can even run the same command on top of any other cloud provider, just like he showed us on AWS, and you can go onto the cloud. So it's the same workflow, it's the same CLI. OpenFast enables serverless development by the way, which uses containers internally, which kind of showcases the side-by-side concept that we're trying to showcase.
Yeah.
Yeah.
Yeah, you can see the basically Lambda in CloudWatch. I'm invoking it. I can invoke this for curls from my gateway directly through basically Lambda's interface or AWS interface, and it works without any changes.
Cool.
Yeah.
Thank you, Pav. Now I would like to invite Yaron. Let me hook up the. Let's see. All right. So you.
Okay. Thanks.
Good. All right. Thanks.
So hi, I'm Yaron.
You can use the clicker.
Okay. I'm Yaron. I'm CTO, co-founder. You have to use the mic. Okay. I'm Yaron, CTO and co-founder for Iguazio. I'm going to tell you about Nucleo, which is our open source framework used by a bunch of people. We'll talk about that. So first, what do we see? The challenges today for many organizations is how to innovate and iterate faster. And that means that usually today development is long and complicated. You have many moving parts. You write code, you need to instrument it, you need to add security, you need to think about scaling, you need to think about all those little details. Then you have a bunch of DevOps tools, or some in terms of machine learning, they call it MLOps, which need to automate the productivity of that sort of artifact. Many people don't write really code that is sort of production ready, meaning instrumentation for logging, thinking about security, etc. So if you write less code and you let the framework do the work for you, there is a chance that you can be faster time to market. And also, we've seen that a lot of people don't know how to write code, which is very, very efficient. Now, this is strange when I'm saying that in the context of serverless, because usually people think serverless is slow. What we'll show you is serverless can be faster than writing your own code. And that really depends on the architecture. So what you need is serverless. You need that serverless to be high performance, not just high performance in the computation engine, but also high performance in the data access and other aspects. And you want it to be federated, because there are very few people that run workload just in one place, whether it's multiple cloud locations, because you need to support multiple regions, or some on-prem, or maybe an edge and a cloud scenario. Now, serverless today have a lot of drawbacks. So when you think about serverless, you're saying that's probably not going to be the thing. I'm going to do high concurrency, real-time workloads. Usually it's stateless, and we've seen that as part of the definition. Serverless is stateless, so it's limited to a set of workloads or set of application patterns that we can feed stateless for. It usually, if you go to a cloud provider, you have only a small set of event sources, which are only this cloud provider. So Amazon will support Kinesis as a streaming. If you want to run PubSub on Amazon, that probably won't work. And other issues, very hard to debug, and also sort of API lock-in. So this is what brought us to bring a new framework, which sort of tries to break some of those definitions. So we provide a framework which is faster than what you can do yourself by writing code. And essentially what it takes is a lot of patterns from real-time, high-performance computing, and it has a lot of parallelism built in. So instead of having a single-thread architecture like Lambda, you invoke it. Essentially, you want to run another request in parallel. Amazon, you need to wait. You know, there's slow start. Wait for a second, it will spawn another worker for you. Those were sort of the architecture of the 70s. There are new modern architectures like Go with Go routines, or Node.js with sort of asynchronous calls. So the idea in Nucleo is that you get a bunch of requests, you spawn lightweight threads, and those sort of handle the different workloads. And this is how Nucleo, a single process, can get to 400,000 events per second using Go, and about 60, 70,000 events per second on things like Python and Java. Other things that we add to support are GPUs. This Nucleo is the only framework that really has native GPU support, very strong partnership with NVIDIA. It's also using Nucleo for a bunch of stuff. And it also knows how to sort of initialize the context of GPUs and all those hard problems to maximize the performance there. Other aspects that you would see typically in stream processing. So many frameworks will say, yeah, we support Kafka, we support asynchronous workloads. But what they do is essentially have some sort of a gateway that convert the stream into an HTTP and then invoke the function. It's pretty hard to do stream processing that way, because if you have a failure, who's doing the checkpointing, who's doing the sharding, the distribution of those streams to multiple workers. So Nucleo does have a framework that allows it essentially, for example, if you feed Nucleo with Kafka, it automatically knows how to scale out and scale up. So for example, you'll take Amazon Lambda and you'll work with Kinesis, and you have 10 streaming shards. It will essentially going to launch 10 function instances, and you're going to pay for all those 10, by the way. Just look at the small letters. In the case of Nucleo, because of the scale-up, scale-out architecture, it's essentially going to launch one process. And as the load is going to be accumulated, it's going to spawn itself and checkpoint and deal with the load. And there are other aspects there. It supports more than a dozen triggers natively into the function, again, not through a gateway. Support a bunch of other features in data science, because we are targeting Nucleo mainly for data analytics, data science, and AI. And it supports statefulness. So you can essentially mount Nucleo function on a volume. Think about the amount of application that it opens up. Nucleo has a state cache, context cache. So I can essentially preserve data persistently in a cache between invocations, and supports data connections. And again, it's about 100 times faster than Lambda on high concurrency. This is just an example from a customer of ours that's using Nucleo for real-time machine learning inferencing. Running his own code on Nucleo saved him half of the amount of GPUs and doubled his performance. Okay? Same code. Okay, running on GPUs with Nucleo is essentially 4 times more efficient than running this code without Nucleo. And if I compare it to someone running the same inferencing logic without GPU, it's like you can't really see the performance, the TPS that you would achieve. So for certain workloads like AI and machine learning, not having GPU is sort of a waste of a lot of energy. So this is one example. Just I didn't mention the users that use Nucleo. There are a bunch of enterprises using Nucleo. One very sort of good proponent is Samsung. Samsung is using Nucleo as their own serverless framework in all their data centers. And there are other contributors, major contributors like Microsoft and others in the framework. Okay, and one important thing about Nucleo is it's essentially not trying to replace containers or Kubernetes or some of those. It's essentially an abstraction layer on top of Kubernetes or on top of Docker. It supports essentially 2 deployment models. One is standalone Docker, the other one is Kubernetes. So if you look at the stack, you have one layer which is the data. And today in the cloud, you have so many options for database as a service or object store. Then you have Kubernetes. What Kubernetes gives you is essentially a transparent, vendor-neutral, cloud-neutral API across all the resources. And also it provides you a mechanism where you can let someone else deal with auto-scaling, security, infrastructure-related things, volumes, etc. But what you're sort of missing with Kubernetes is you still need to write a lot of YAMLs, and you need to generate code, and you need to do all the instrumentation and think about logging and ops and DevOps and all that. So this is essentially what Nucleo is trying to address, is provide auto-generated code and Docker files and YAMLs and all that based on very high-level descriptions, automate all the development and operation flow, instrument your code with logging, security, and other things. Okay? And it maximizes performance and resource efficiency by using all those low-level tricks that none of you really want to deal with on a day-to-day basis. So I'll show you a small demo before I'll dive into the use cases of what's Nucleo.
Just hold this for a second.
Okay.
Do you have USB-C?
Yes.
Okay. Just do this slide. Okay.
So again, Nucleo is sort of very comprehensive. It's not sort of a small tool. Nucleo is about 80,000 lines of code. I think it's one of the most sort of amount of code for a serverless project out there. It contains UI, CLI, RESTful API, that all of those are also handled with security and other aspects. We also provide a managed service around it for with other services as well. But anyone can just go and install Nucleo and use it. So, I went into a project. I want a running function. Let's create a new function. I don't have to work hard. I essentially have templates. Those templates are loaded from a Git repo or local repo, so people can just go and add their own template.
I want to use this mic and use both hands. Probably need both.
For example, a function I like to show is sort of a natural language processing function. So next page. Okay, so I'll just go in and load a function. Now, Nucleo supports also templating. So when you create a template, you can even say what sort of how the UI needs to look like. That will sort of autofill various parameters. There's like a schema for it. And then it essentially creates a function. So a function, you have a very comprehensive UI. Again, you have in the UI, you have the ability to go and edit code. You have the ability to sort of go and test the code, sort of a built-in postman. The code doesn't have to be entered this way. If you really want to do a CI/CD pipeline, you could use GitHub and sort of webhooks. You can load from an archive, like a zip file. You can load from a Docker image that's already pre-baked. You can just load the function. So the only thing left to do is just to deploy the function. And if you go and open this small widget, talking again about containers, what this thing did is actually taken my code, all my definitions, and generated the container. You see it took like a couple of seconds. But if you go and look at the log, it's essentially going and building a Docker image and pushing it into a Docker hub or a Docker registry somewhere. Okay, and now I have a function which is running. So I can just say, I'll put some typo here on purpose. Okay, and now it's translated my text. This function, essentially what it takes some text, and you can see there's instrumentation of structured logging built into the function. So that means that I automatically, all this structured logging is going to go to the log sync. And log sync, there are multiple log syncs, like ELK is one of the options of log sync. So that means that all your logs will go back to the UI, but also to ELK in this case. Okay, so I can instrument my code really easily with structured logging. I could get my response. By the way, we can change the logging level. Let me do this thing. I can change the logging level dynamically, whether it's in the function through the testing, or that's something that's not so good in Lambda. If you work, you don't try to put too many debug logs, because then it's going to cost you in CloudWatch. So
These logs are local? These logs are local?
You have a log forwarder built in, and you could define where is it forwarding to. In the managed platform, obviously, you don't need to do anything, but like in the open source, you need to say, this is my ELK, or my app insight in Azure, or sort of whatever is supporting the...
You're not paying for CloudWatch?
No CloudWatch for you. Yeah, we do support like App Insight, and other, the cloud providers like Azure contributed the support for their logging. And what you can see here is that you can see the actual logs, and so that it corrected my text. You see, essentially had this correction, and we can even see the sentiments. So you can instrument your code without thinking about where's the logger, who collects it, etc. Other things here is like the configuration. You could go and configure. You could see CPU resources, GPU resources, and all those things, environment variable, labels. You can say, you have even advanced Docker build options. Like you can build from an image. You can say, you can have on builds, all those things built in.
Can you go up a little bit? I want to talk about this. Just go up, scroll up a little bit where you configure the memory and all that. So, so I want to kind of take a moment to just recognize the fact that all the cloud providers have their limits and constraints. So running something, and this OpenFaas has the same capability. You can manage your memory and limits and CPU and all that on your own, because it's actually running with containers. So that's a huge advantage of using something like that, apart from the fact that you can run it on-prem. So just keep that in mind.
Yeah, and another major difference here is that the number of replicas in Lambda is always 0 to something that you don't really know what's the something.
Right.
And here you can configure what's the starting point. So many applications say, you know what, I want to start from 1. I don't care about the sort of the cost penalty, and I want to end at 10. I don't want it to start going wild. So you can essentially go and configure those things.
Right. And you can run long-running processes as well, because you can manipulate that limits in here.
Yeah, and through APIs you can also control those in runtime. Again, other unique things that I mentioned is that you have the support for volumes. You can actually go and mount volumes, Kubernetes volumes essentially, into those functions, and a lot of flexibility around build instructions. One thing we got from a lot of enterprises is being able to shut down internet access from the functions, or even during build operations. So, because we're working a lot with the enterprises, then we sort of have to do a lot of that sort of work. Another important thing is around triggers. As we mentioned, the triggers are built into the runtime engine. So if you say Kafka, you just go and put the Kafka endpoints, credentials, etc. Nucleo would automatically do the checkpointing, rebalancing, and all those sort of heavy lifting things for you. If you do HTTP, for example, you have the ability to configure everything, including like basic auth and cores and all those things through the standard Kubernetes ingress definitions.
So here, I mean, these triggers, you can imagine Kafka running on as a server or in containers, and then you can just use functions to interact with it using the triggers, the huge use case.
Yeah, and you're not limited. One of the nice things is the API is the same API regardless which trigger you're using, whether it's Kafka or Kinesis or Event Hub. That's not the case for Lambda. If you're using Lambda and you're using Lambda with Kinesis or Lambda with API gateway, your event signature changes. That means you would actually need to change your code. So many times what you'll do, you want to use HTTP, train your code, see everything is working, and then transfer it to like a stream or MQTT or whatever. In Lambda, you actually go change the code and then run it again. So how do you know if it's working and tested if you just changed it? So you should ask them those kind of questions. So, okay, moving back to the presentation.
Yeah. Okay.
You want me to take it from here? Or?
Yeah, just take it out if you want. Go back to that. I'll get it from the other side.
Okay.
Do you need this machine anymore?
We'll need it for the data science demo.
Oh, okay.
Okay. Actually,
all right.
Clicker. Okay. So one of the main use cases that we use it for, and a bunch of users use it for, is data science. Data science.
1 second.
Thank you. So data science and data engineering. So the general idea is, most people won't use Lambda for some of those things. Actually, if you go to Amazon and you look at Amazon flagship project for machine learning, it's called SageMaker. They're actually not using Lambda. Guess why? Because Lambda doesn't support large models. Lambda doesn't support concurrency, et cetera, et cetera. So they reinvented another form of serverless. So Nucleo is something that can deal with all of those different use cases, whether it's ETLs, it's inferencing, even machine learning, hyperparameter tuning, all those cases because of the different mechanisms of triggering that it have. So I'll show you a couple of use cases of essentially using all of that. We'll also use some magic that we're doing with Jupyter that you'll see how we can automatically transfer notebooks to functions. So this is an example of an application. This is a sort of a real-time analysis of trading data in banking, in financial services. So what you see Nucleo is doing here is essentially, first thing is ingestion, is I need to collect data from Twitter. I need to run some sentiment analysis on that data in order to figure out that Google is now sort of in good shape or a bad shape, etc. The same doing for real-time trading data, so stock ticker information that's feeding in real time. I want to take that data and even add labels, add other meanings on that data as I ingest this into a database. While I'm doing that, I can use other container services. Again, Nucleo is sort of event-driven, but if you want to run analytics or something like that, you would use another framework like Presto or Spark and Jupyter. And then eventually, one of the things that you want to do is take all this data and show it on a dashboard. This is where you will use something like Grafana, which is, again, a container and not necessarily a function. And one of the widgets within the Grafana is sort of a stock ticker that requires some API. So you don't have a built-in stock ticker widget within Grafana. So essentially, there's a function that every time Grafana says, give me a stock ticker UI, essentially generates an AJAX view for that. Okay.
Just wanted to quickly mention that, in this scenario, you're not locked in with at a cloud provider. Sometimes the data is, like you showed, some World Trade data. Financial data could be, needs to be secure and needs to be on-prem. With this, you can use that same data securely within your, inside your firewall, but still use the flexibility of using the serverless tech.
So the thing that most data scientists do or data engineers do, they use notebooks. They don't like to open UIs like the one I showed you before. So they will write a notebook that says, here is how I write some machine learning code or some data analysis code. So this is an example. This code, let me increase the size.
That's Jupyter Notebook, right?
Yes, Jupyter Notebook. So pretty standard among data.
For
people.
AI and ML use cases, right? Yeah.
Yeah. So what's a notebook is anyone who knows what IPython is essentially a way that you can run portions of Python or other languages and like do Shift-Enter and it runs it. So essentially, I'm going to run, the only thing I'm adding to this notebook is like something called import Nucleo. And then I have those magic commands, they're called magic commands. And in those magic commands, I'm just instrumenting my code. I'm saying, you know what? If you're going to go and deploy this code into production, I need those sort of environment variables and potentially I want to configure a trigger, a cron trigger that is like every 5 minutes. And you know what? I need a baseline Docker image called Python Jessie. And maybe I need to install some Python packages. So now it's essentially not going to do all of that in the notebook. Some of it will. It actually, the Python packages and environment variables are going to be set locally. And I could write my function that essentially goes and goes to the stock service, reads the stock data. I have a built-in emulator that's loaded with the import that I can essentially go and test my function and see that it actually works. And when I finish, I do a nice trick, which is essentially just asking Nucleo to deploy the function. And then I'll show you on the other cases, after I tested, I can essentially go and do the deploy. And what you see, it's essentially what I've seen in the UI. You can see it's generating a Docker image, building it, deploying it into production. And then I could just go and ping that function and see that it works. So we can do the same, not just for this. We can do the same for other types of triggers, like Twitter. Now, the interesting point with this Twitter example is that there is no trigger called Twitter in Nucleo. Because usually what is a trigger is like HTTP or something that's a push. Twitter is actually a pull. I'm going to Twitter, I'm fetching some data. So Nucleo has some trick that essentially allows it to turn itself to a service. It's something called init context. I'm not going to explain it here. But I can essentially go and tell the Nucleo function, go bring up a thread that will start reading data and treat it as your event. So I can essentially go and support any number of triggers I want with this trick. Okay, and again, deploying, and I could see my function being deployed. Okay, so that repeats itself in all those demos. And then, by the way, if I want to run query on the data, I can just go and use something like Spark to query the data that was ingested. Now, Spark again is a container; it's not a function. And I could use Presto, which is a sort of an analytic database, to query that data, or Pandas, all those. Nice tools for data analytics on data that was sort of ingested by this function. Okay. Maybe so. A couple of last slides, and so we spoke about. Sorry.
Yeah. Some there.
So we spoke about this example. Sorry.
You can go back on the red button.
Yeah, so we spoke about this example. Again, there are many examples, and we have a repositories of end-to-end examples of sort of analytic and data science workloads. This is something used in production by one of the biggest Asian telcos. essentially think like they have network telemetry, lots of data coming from network routers, border gateways, etc. They need to correlate that, understand that there is a problem, and notify about the problem, and maybe even fix the network before it actually had an issue. So that's what you see here in the diagram, that when they predict that the network is going to have a failure, upfront they're going to reroute the network to avoid the failure or the cybersecurity attack. Now and the architecture for that, again, is same type of architecture. Is you use a function as the way to collect and ingest data from all those different sources. Syslogs, you're running NLP, natural language processing, on syslog to figure out from the logs what's going on in the network. You're taking network data, statistics for network and net flow, all that data, and you're taking real-time telemetry. All this data is crunched in function, inserted into a real-time database. Then you have container services. They do the exploration on the data, tagging, labeling, as well as machine learning training. In this case, is using scikit-learn and Dask. Dask is sort of a parallel Python framework. All of those, the Jupyter, scikit-learn, and Dask are running in containers. And then that is automatically generating a function based on the model. Once the model was generated, it's automatically generating a function that does the anomaly detection. And that function will also feed into the Grafana dashboard to essentially show the anomaly as it's being created. So this is just to open your minds that serverless doesn't have to be something just responds to an HTTP and that's it. And the second point is that service usually coexist with containers. So just to summarize, serverless is essentially rapid development and operation for microservices. That's the way I view that. It eliminates the scale, operation, and cost challenges. Again, it's auto-scaling. If you use the right framework, it also knows how to do pretty high performance. Nucleo has all those advantages that we talked about. It makes your application faster and simpler, not just simpler. Support many of those data sources built in and comes in open source. And for some people, when they say service, they really want someone else to manage it so they can come to Iguazu. So thank you.
Thank you, Yaron. We'll open up for questions, and it can be interactive discussion. So any questions on OpenFaas or just how you feel about serverless next containers is something that we can talk about. Anybody? Yeah. Let me get you the mic. Speaking to the mic. Recording.
Can you go back 2 slides behind, actually? Actually, 1 slide.
This one?
Yeah.
Okay.
Here, actually, what is the real advantage of doing this way versus the regular streaming pipelines, whatever is happening on a...
So what would be the alternative?
What is the real advantage here? Because I see like the data being ingested into like some sort of Kafka or something, wherever.
Yes.
And
first, some of the data, it's not really shown here, will be ingested into that function through Kafka. So that function would actually listen, for example, the syslog data could actually be ingested through Kafka. In some other cases, you want the function to go and fetch. We've seen a lot of use cases with customers saying, we have like an Oracle database or we have some infrastructure. Go every 5 seconds, go do polling and fetch data from there.
Okay, so the change data capture is being done by the fetch your fast function. Is that what it is?
Yeah, now remember that there are solutions for stream processing, but they have a lot of limitations. Usually it's like Java mainly, and also they're only sort of being pushed at. You cannot go and do polling of data. All the things that automate your code to production, that instruments your GPUs, logging, etc., are usually not part of a streaming framework. So what we've introduced is something that provides all the capabilities of like a Flink, etc., in terms of streaming, and all the capabilities of Lambda sort of coupled together. So you don't have to choose. You could use one framework for different types of workloads.
So that data is crunched through Spark here? What is it? Is a Spark process crunching the data? Who is doing the
in this case, there is no Spark. The function themselves are processing the data.
function itself?
So what's the function doing? Think the Kafka is generating, let's say, a syslog, which says like an error, timestamp, a bunch of things from a Juniper router. So that essentially there's NLP tokenizing this sentence saying, you know what, that's a bad issue, the bad problem. You know what, maybe the previous state is such that if I get this thing, I can understand that there is an anomaly. So all this data that's being crunched is sort of pushed into like a time series database, because once data is being sort of parsed, it becomes numeric values. So it's much easier for analytics.
One other question. So maybe like in a Spark, you create a data frame and you do the transformation of the data based on the log formats, whatever, right, JSON, whatever. But here I see like you defined a function, but you didn't say what format the incoming streaming is coming in what format.
Yeah, but that's part of the implementation of the function.
Okay, so it has to be done.
The function will get a JSON and say, you know what, do parse the JSON, look at those fields, etc. But the nice thing is that the function could be just simple Python code that you debug on your laptop and push. You don't need to be a Scala expert or,
Okay, I see.
All the parallelism is handled by the frameworks. You don't need to think about that.
Sure. Thank you.
So is there any limitations on the memory and the runtime like AWS Lambda imposes in Nucleo?
It's a great question. No. Again, you can configure all of those things, part of the function spec, etc. You could define what's the minimum, maximum memory. The rest is sort of depends on the physical limitation of your cluster. It runs on a Kubernetes cluster. In Kubernetes cluster, you can apply limits and reservation to a namespace. So you can put a bunch of functions in the same namespace and restrict that.
So are you running the containers when you get an event, or the containers are running all the time?
The containers are running all the time, and there is a slow start mechanism. So essentially, if there is not going to be an activity for X amount of time, there is a service called scaler that's going to shoot it down and assumes the triggers. So the next time an HTTP request arrives, is essentially it's routed to sort of a standby thing. The standby thing wakes up the function and pushes the call to the function. So if you've specified scale to 0, meaning the number of base replicas by default is 0, this will be the behavior. After X amount of time, it will shut it down and then restart on the next event. For some people that do like streaming or low latency, they will actually keep the number of minimum replicas to 1, or maybe even 5 if they know there's a burst of data. And through the API, you could even change it, because let's assume you know that, 8 a.m. I'm going to get a bunch of events. You can essentially go through the API and say, turn it on.
Okay, thank you.
I think that's on the cloud provider, you don't have a choice. Here, there is no cold start if you don't want to. You can have it running, right? Yeah.
If I'm already using AWS Lambda and I see that there are some advantages with respect to cost and performances, and you want to switch, can you still run on AWS?
Yes, well, our public service is on AWS, and you can go and install their instructions how to install Nucleo by yourself on AWS.
Cool, thanks.
As part of the Git repo, you have installation instructions for every cloud provider on GKE, AKS, etc.
I'm using Lambda 2 at AWS, and there are 3 very common problems, so to speak, with Lambda itself. Problem number 1 is you don't have local development environment, and I can clearly see how OpenFaas solves that. Problem number 2 is challenges with debugging your functions, right? And I would love to hear more and how that debugging process looks like if you put that in a local environment. And challenge number 3, if you're writing for Lambda, you're writing for AWS. If you want to port that to Google Cloud or Azure, you have to rewrite at least part of that. Can you guys speak a little bit about that if you have a solution for this? Thank you.
Yeah, you're right. So one of the key things, and not just with OpenFast, but a lot of the open source serverless solutions focus on the container as the unit of operation. So you talk about local development environment, because you can run Docker Swarm and OpenFast on top of that, and you have your local environment. For debugging, it would be the same as debugging a normal application that runs in a container. You can either tail the logs locally, or you can execute your code or exec into the container. All of those things are possible. And then the third you said was migrating to a different provider. So again, since containers is the unit of operation, anywhere you can run a container, you could run OpenFast. So the migration, and we show, and Pav showed off that we can sort of integrate with several different orchestration engines. So Kubernetes is one, Docker Swarm is another, AWS Lambda is one option. There's several others, and if one isn't there to meet your needs, I mean, it's easy enough to add your own. But again, it's just containers at the end of the day, so wherever those run, you're safe.
So to his point, I started working with OpenFaas and Swarm initially, and you can take advantage of the same. So Swarm works with your basically orchestrator, right? If it's, Swarm, OpenFaas. If it's Swarm, it works with Swarm primitives. If it's Kubernetes, it can work with Kubernetes primitives. So if you want to do memory limits, right, any kind of caps or anything, what you can do in Kubernetes, you can do the same thing in Swarm. And if it's not in there, you can add it because, again, it's working with together. It just adds another dimension to what you already do with containers. So, if you do Docker exec, you get into it, you do run Docker logs, you can continue doing the same thing. What it takes away is you don't have to worry about building out infrastructure, building health checks. You can build whatever containers you want, right? We're not limiting you to a specific language on the workload time. Those are typically kind of like, could be an H or not, but what we basically provide you is you can build whatever container you want. You can execute it in the same kind of way that you work with containers, monitor, log in, day-to operations. What you just don't have to worry about it when you crank out the code, that you don't have to worry about underlying plumbing, right? If you're business value by writing code, you don't want to start teaching all your development staff of what underlying overlay networkings look like. So that's kind of what we add, and we're just trying to emphasize that it is not just one in lieu of another, right? It's not containers versus serverless. It's just with serverless 0.0, we're like trying to talk about that, like the next generation where serverless is going to go. It's just going to be ubiquitous, right? Around OCI, around Docker images. You can capture what you want, your workload inside of that container, inside of that image, and then you can share that information. You can share that image, that workloads. And if it's appropriate, workload to run inside of serverless, that, you do it, right? It becomes very ubiquitous.
That's a good point. Yeah. I just want to mention, you said problems, right? So for security reasons, we have all done VPCs on AWS. It's super slow with cold starts being really high. Here you can see you can use your own network partitions and whatever architecture you have in your organization, right? It just becomes easy, right?
Yeah, maybe I can also address the question. So we've taken a lot of work with, one of the things unique about Nucleo is that our developers are also using it because some of the other platform services we provide are using Nucleo. So they had to add instrumentation because otherwise, it's a pain for them. The best way to get a software developer to do something is to make him sort of eat his own dog food. So you can see that we've put a lot of emphasis on logging, debugging level. We have SDKs to the different languages. You've seen the integration with Jupyter, which is all about sort of allowing someone within an IPython notebook to sort of debug his stuff and then click deploy. The other thing is really what we see is something helping our business is people are hesitant from saying, Lambda, because IT wants Azure because whatever Office 365 reasons. So now part of the things that we work with enterprises is providing them a multi-cloud solution, and we have a managed offering that runs in multiple clouds.
Yeah, what you're saying is great, but I would speak from the standpoint of ignorant businessman. And for me, Lambda is serverless. That means I don't care what infrastructure is behind. What I saw in a fast presentation is that you write your function on Kubernetes and then you just create Lambda function out of that.
Yeah, but that's different in Nucleo because Nucleo has a managed service and you would just go through a portal, you get an email, just like Lambda, it's all fully managed. Again, you could install the advantage open source, you could play with it on your laptop, you could do whatever you want. People install it on Kubernetes, on large clusters, but if you're sort of into this model of, I want someone else to outsource this for me, then that's what we're doing.
Okay. Yeah, I just would love to see the streak you showed with Lambda with Google Cloud and Azure.
So with a provider, right? So what you saw with Lambda, right? It was a provider. There's a provider SDK they can work with OpenFaas, and you can build provider. You can run it in Google. So as long as the target accepts a container image, that's basically what Lambda does. It takes a container image and it repackages it in whatever that format it does. And that's basically, and why the reason we kind of talk about serverless like this too is that it's about semantics. It's about simpler semantic model of development, not have to worry about certain things that are not part of a view, right? It's about, again, business value, right? And that's the difference.
And yeah.
I was going to ask, I think the benefits of these open source solutions are really clear in terms of avoiding vendor lock-in is a huge one, and also being able to take advantage of just kind of the serverless architecture. At the same time, I wonder if you guys have done any analysis of cost of running the infrastructure yourself versus on a public cloud, and if there is any line of sight to if it does line up exactly to getting these solutions to be just as cost effective, or maybe they already are, I don't know, as the public cloud solutions.
Yeah, so I can speak to the OpenFaas. Like I said, it's a very small footprint to add OpenFaas to an existing Kubernetes or Swarm or Nomad architecture. And generally, most people are using some sort of orchestration engine if they're already into containers. But we also provide like the provider like we showed with the Lambda. So if you don't have your infrastructure, you can also leverage the existing cloud providers. But generally, larger companies have their orchestration or containers already running. And if you want to enhance the developer experience with a serverless environment, then adding OpenFaas on top of the existing infrastructure is little to no cost. I mean, of course, scaling to your function and all that stuff, but the core function is, or the core pieces are very lightweight.
And you're right. So there are two tenets that kind of, if you're just coming from a serverless perspective, right, and you've done Lambda and all that, it's been, burnt into the mind that, scaling and infrastructure, as I said, like infrastructure is not your concern, and it kind of, like, you're talking about infrastructure. The whole point that we're trying to make was, I mean, if you are like, you talked about businessman who was doing a small thing. Yeah, absolutely use Lambda or just the whole cloud provider thing. Use the local development part and then run it on the cloud. But we're talking about these enterprises who are not able to use the benefits of serverless, which are event-driven architecture, the new serverless architecture, the scale to zero, right? Those functionality, the enterprise is not able to use because they don't want to go to the cloud because of whatever, compliance, security, data, whatever, right? So you can bring that to the enterprises, run it on-prem, on your own infrastructure. Maybe they have a Kubernetes cluster, you just run it. So that's kind of the whole point that we're trying to make. I mean, serverless, by definition of, not managing the server still exists. But this is a special case where we want to bring it onto on-prem. Give those people a choice, right?
By the way, it really depends on the type of workload. Because if you do a GitHub hook every 20 minutes, probably Lambda is what you need to stick to. If you're trying to run sort of more concurrent workload, I mentioned that around Kinesis streaming, that would essentially go and consume 10 functions, and you'll see that in the build later on. And in our solution, it will only consume one. Or if you're going to do inferencing, we can attach GPU that costs you a couple of dollars more per hour, but will drive 30 times higher performance for your inferencing. This is where you'll see the gain. So for small customers that just need few functions to do their homework or whatever, I wouldn't suggest to use our solution. But for enterprise that anyways they have a cluster of a bunch of nodes, we do have all the efficiencies around scale to zero, et cetera. And today you also have automations that you could increase the cluster size dynamically. By the way, there are also solutions for increasing the container dynamically, like Microsoft has HCI, and Patrick is to sell that, or there is Fargate, etc., where you can actually be billed by the container runtime time. So if you use those, then essentially you get sort of the same sort of billing. But again, the way we would, if you have enough capacity, start thinking about it. If you're just running sporadically a couple of functions, use Lambda.
Yeah, it's a good point. The workload is what you need to look at, right? There's no magic here whatsoever, maybe a little bit, but typically it's about the workload, you're right, and it's about trade-offs. What's important to you, right? You're running on-prem, do you really care about scaling compute, or you have pre-allocated certain amount of capacity that you're working with? And it's all adjustable. We can actually adjust functions for basically scaling all the way to 0. We can keep them running warm, if you will. It depends, again, what demands you have. And it's always about trade-off. Any time you design something, you're thinking about trade-off. Does it make sense to run it in a container? Does it make sense to run it stateful? Or does it make sense to run it more with a function like an interface, something that a bit more ephemeral? Just to add too, with OpenFaas, there's also a cloud solution that we kind of, you can take a look at, that kind of a more of a managed service that you can take a look that we have out there right now.
Hey, how are you? So there's an increasing trend to run serverless code at the edge. You know that you have Lambda at edge, you have Cloudflare workers and stuff like that. Do any of these platforms integrate with these technologies?
If you don't mind, I'll give it one quick shot. Yeah, so originally when I started looking at OpenFaas, I was looking at running it on a single board compute. We had medical equipment that we wanted to read data off, and we wanted something very simple that could pretty much serve as a kind of a gateway in a way to the, something maybe in another cloud, and at the same time could do some maybe basic processing. So we're actually looking at putting some of the interfaces, and we're going through design of putting OpenFaas on Raspberry Pi, so we can actually run things closer, like at some, medical centers or some other organizations like that too.
It's actually a great question, because a couple of months ago we made a joint announcement with Google of essentially providing an edge for retail stores. So it's essentially using Kubernetes and Nucleo and a few other components, so retailers can essentially take all the camera feeds, process them locally, run artificial intelligence, image recognition, and also store all sorts of logic, and feed it to Google. Next week you'll hear another announcement for a different cloud provider around something similar, but definitely the advantage of those serverless functions is that you can go and develop them in the cloud. You could do training, you could do all those things. It's an artifact, it's a container. So eventually the only thing you need to do is just transport that container to a local repository at the edge and run it against various invocations. Now, the fact that we can also enumerate different types of invocations to the same signature, whether it's like Google PubSub or Azure Event Hub or Amazon Kinesis or Kafka at the edge, means that you can actually transport the functions to a different location while not really changing the function code.
Yeah, sure. So I was wondering if you guys have some sort of performance and cost analysis against your product and AWS Lambda. I'm using AWS Lambda heavily, and I have done some cost analysis within myself, but I wanted to see if you guys have some sort of artifact which we can use and see how they compare.
I think it's very workload specific, so if you want, we can go over that and see. Again, if you're using something very sporadically, there will not be any gain. If you're sort of using functions more heavily, there could be even a 10x gain in some cases that we've seen.
10x in performance, and how about the cost?
I'm saying cost performance.
Okay.
Because it's auto-scaling, it's always cost performance, okay? Because if you have a certain workload of, let's say, 10,000 events per second, then the number of function will be driven dynamically.
Okay.
So like he was saying, it's more about the performance gains, both in code performance, developer performance, and operations performance, less about the cost. The cost is going to be close to the same because of the operation model, right? You start a container, you run the code, you kill the container, and you're done. But the real benefits, the true cost gain is in the speed of development, the ease of operations. Your CI/CD pipeline is consistent across applications and serverless. You have local environments. All of these benefits that come with using containers in a serverless world where developers only care about the code that's executing. if there is a cost difference, it would be worth it, right? Because you're gaining so much business value everywhere else versus the execution of the code.
Sure.
It's systemic qualities, right? Which ones you're looking at, right? And cost is one of them. Again, it's going back to where you're willing to make a trade-off, what type of application and workloads. And I think it's all going to boil down in this conversation to what are those workloads that you're running to, and that's where your cost truly going to, come in. And
yeah.
Okay.
Another point is you need to look at the overall cost. Sometimes people don't look at the CloudWatch cost, and they use SQS as an SNS to just look through data because it's stateless. So if you take all of those things, you may end up seeing that it's not that cheap. I've seen a bunch of blogs about it that just Lambda was that cost, but starting to add everything, it's like
that's to the point. So now, if I am coming from AWS Lambda and I have to choose, I'm hearing that OpenFaas and Nucleo kind of competing, or I don't know if you can say competing or complementing. How would you?
I think they go to different categories. First, Nucleo has a managed offering. So if you're sort of used to having a managed offering where you don't care about anything, you just get everything up and running, logging, monitoring, telemetry, integration with data, streaming, all that, then Nucleo provides an offering. I'm not aware of something that OpenFaas provide in that space. The other points is even if you want the open source, then they're trying to address different types of application. Nucleo is sort of a heavy-duty tool. Go to see some blogs, or there are a bunch of places that sort of say Nucleo is way better than Lambda in certain areas. We're not trying to be match Lambda. We're trying to be better in Lambda in certain areas. And I think if you're into those areas of data processing, analytics, machine learning, etc., Lambda is just not a good fit for you, and Nucleo is way better in those aspects. As to OpenFast, again, it's a great tool. It has a huge community, a lot of sort of plugins. But that's if you're in that mindset of want to sort of take it and sort of build it and work with it.
It's a big space in general. The whole in 2016, I guess, when the OpenFast started, started with a basic manifest, right? HTTP port 8080 and just basically able to auto-scale, right? And that's kind of was the first requirement, if you will, that started the project, and then every developer kind of got onboarded based on those principles. So OpenFast is built by OSS principles, and modeling contributions since the day one design are built basically by a community of people such as you, who are interested in contributing and looking for a specific, something pragmatic they want to see in that product. And that's kind of what we strive at OpenFast, is just to bring that type of experience. So.
Yeah, I just want to say, you can control that code, you can look at that code, it's open source. Nucleo has a component to that. Iguazio, I guess, is the open source.
Again, there are a bunch of other contributors.
Okay.
And there's a very active Slack channel that you can join.
Right. So, and the other thing, on that discussion that we were having, it's not, you don't compare AWS Lambda with this projects, right? It's just one component of serverless. Serverless is not AWS Lambda. That's a misconception. AWS Lambda is just the fast piece of it, right? But then when you do serverless on any of the cloud provider, I'm not trying to pick on AWS or anything, but you pay a lot. You pay for API gateway. You pay for CloudWatch. You pay for SNS. I mean, even to get logs, you can forward your logs from CloudWatch to anything else, but you pay for that, right? Here, if you have an existing infrastructure that, if you have Splunk Enterprise, for instance, on your enterprise, why would you want to spend that extra money? So I think the cost analysis is a little hard unless you exactly know what you're doing. Like Yaron mentioned, if you are doing ML and AI workloads, data streaming, you should give a look, because it specializes, that platform is specialized for that, and then you get all the other bonuses of using your infrastructure. If you don't want to manage, of course, you can go to their cloud, and I think OpenFaas has their own cloud, so you can do the same thing if you don't want to manage it, right? But you still get the benefit of configuring what kind of environment you want. Other benefit I feel, this is a container conference. I mean, we saw so many announcements today about all the goodies that are coming to containers. All those can be utilized. I'm sure multi-architecture builds, that same pipeline you can use to build containers, and then that container can serve your function. So you have to take it on a holistic level, like what we are trying to showcase. And it's like more of a question to everyone, and we would definitely like feedback on that, saying, okay, what do you think? I mean, we will share their contact information. Please feel free to talk to them, right? You have anything to say? Somebody asked, like, can you, if I have existing workloads in AWS or Azure or Google Cloud, what is the way to come to one of your platforms? Like, can I just import them, import the functions? Is the signatures different, or what's the best way to do it?
So currently there is a slight difference on, as I mentioned, a function signature. We did work within the CNCF to standardize that. There's something called cloud events. I was part of that standardization. So essentially across functions, and I believe also OpenFast supports cloud events, etc. Azure does support cloud events. I think Google Function also supports cloud events. I think Amazon is sort of still not there.
Yeah.
So there is a way to port events between frameworks. There are other things that we really didn't want to copy. For example, in Amazon, I mentioned that every trigger has a different signature, and we made this point to Chris Munz from Amazon, say, you want to support cloud events because it's going to help your customers, not me, just because for them to switch between SNS and Kinesis is going to make their life easier. So there are some things we didn't want to copy, and we want to keep them sort of right.
Right. You have anything? So tell me about some of the features that usually are required for like end-to-end, like app development, right? Things like service discovery or DNS, like the cloud providers have their own tools, own tool chain. So can you just talk about that a little bit?
So at least from our perspective, again, we use Kubernetes and Core DNS internally. So within the cluster of functions and containers, you have sort of a DNS, and we also orchestrate external DNSs to users, and they can also use their own DNSs. So we manage that.
Similar here, we are basically running on top of the Kubernetes swarm, so we use the underlying discovery system in the same way.
I just want to mention, there is a blog post from one of our other core contributors, Stefan Pordan, who works at Weaveworks, who integrated Istio with OpenFast, so you can bring your own if you're more comfortable or have something already set up. You can plug that in on top of the OpenFast, but much like Nucleo here and probably a lot of the other open source serverless frameworks, we're using Kubernetes natives or Swarm natives, and so what comes with the cluster is what we're going to be using.
So I just wanted to highlight that the point that this makes is, if you have existing hardware or existing platform that use certain tool chain for doing service discovery, DNS, whether it be Kubernetes, Docker Enterprise, or Swarm, you can still use the same things for serverless. So you're kind of bringing together all your learning and knowledge that you have spent time and not spending money on doing, or money or knowledge to do something different as per the cloud providers, right? So it's kind of a, you're just reusing your knowledge base.
Right, that's one of the key things with what a lot of the open source frameworks are doing, and even like Knative is another, using common tools like containers and using the orchestration native infrastructure and all of the common tools to make the serverless experience easier to transition into and not make a special case because you have to, for example, upload a zip file to a website, things like that. So bring it into your common workflow and make it a seamless experience.
Just add in one thing, if you get into containers and you start getting that into production to your teams to start supporting, and you start realizing a lot of times, oh man, I got CI/CD, I got 40 people, they have to figure out how this whole promotions process works, right? And there's also, you get used to working within certain paradigms within platform you're in, whether it's Swarm or Kubernetes, you got secrets, right? You want to be able to manage your authentication data or your configuration data. OpenFaas, you can run your serverless in one namespace, right? And you have your data, whatever that is, right, on another namespace, and you can use DNS to talk across, but you can use secrets, right, share them, or I mean, you won't share them across namespaces, but you could use secrets that you can read that data out of it. So you can use whatever the underlying platform provides for you. So there's no difference there. It just makes it a lot easier.
Right. Another point that somebody talked about legacy apps and stuff. So you have legacy apps. We saw the whole week that you can take legacy apps and you can containerize them. Now you have this opportunity to use events to kind of trigger things and kind of work with those applications as well, because they're all containers now. So a lot of opportunities. Windows containers can participate in the whole of this process. So I mean, there are a lot of all the goodies that you get from containers are coming to the same thing, and you're just slapping serverless on top of it, right? Another question I had was, how do you deal with secrets? I thought somebody will ask the question, but it's important because everyone asks me.
Yeah, with Kubernetes, like Swarm or Kubernetes secrets support basically out of the box, if you want to call it that. There's basically a YAML file that you specify the secret name, and it works the same way. And you can use actually OpenFast CLI to create secrets, which basically gives you kind of a nice little wrapper around it, or you use kubectl to create your secrets and then basically consume them within your application. So.
Yeah, so I also showed before that within the configuration, you could say which secrets you want to essentially mount into the function, whether as a file or as an environment variable. There are some advantages as a file, you're probably aware. I don't think secrets is good enough in many cases. What we have, especially on the enterprise platform, then we also have the notion of sort of random tokens that are sort of generated to the function, and those random tokens define the access from the function to the various resources like data and others, just like I think Amazon has like execution roles. And we're also thinking about another mechanism that will sort of be more hardened than sort of secrets, also talking to other vendors about it, is essentially to use PKI, because the problem of the secrets is that on the same cluster I may have different workloads, then I could essentially mount the same secret to also some intruding function or whatever. So there's going to be a mechanism that we're adding with PKI that essentially when you're generating the function, you have to sign it with a public key, and the infrastructure knows how to decipher it. But again, a lot of our concerns are, again, because we're working with enterprises, and many of them are paranoid, especially network operators, then this is one of our key concerns is security.
Awesome. Any more questions? Okay, I'm just gonna just share the contacts, and then if you still have questions, we can go with. Those are all Twitter handles. Please feel free to tweet any questions or just reach out to them if you have any more questions on their platform. Again, both these projects have open source, so go ahead and check it out, contribute. And if you have any questions for just serverless in general or containers in general, you can also contact me. I worked for serverless for 1.5 years. Cloud events came out from CNCF, worked on that as well. And work for Docker. So it will be interesting to hear from you your use cases, specifically your use cases in the enterprise. I would love to, I'm sure they would too, love to have a discussion around that, right? All right, if there is no more questions, I can give half an hour back. Yeah, all right, let's call it a day. Thank you, guys.